Right now, 13.8 billion years after the Big Bang, you are sitting at the center of everything we can see. Beyond the farthest star, past the most distant galaxy, lies an invisible wall that no telescope can pierce and no light can cross. This is the edge of the observable universe. But what happens if you could somehow reach that boundary and step outside? Would you find more space stretching forever? Or would you discover something that breaks every rule of physics we know? We are about to journey beyond the possible and into the impossible. Prepare yourselves. We begin. You are standing on the shore of an infinite ocean, but you can only see as far as the horizon. This is exactly what we face when we look into space. Light from the most distant objects has been traveling towards us for over 13 billion years, racing across the cosmos at the ultimate speed limit. But here is the twist that changes everything. The universe itself has been expanding while that light traveled. Picture a runner on a treadmill that keeps speeding up. The light is the runner, and space itself is the treadmill, stretching beneath its feet. When we peer through our most powerful telescopes, we see the cosmic microwave background radiation. This ancient light was released when the universe first became transparent, just 380,000 years after the Big Bang. Before this moment, the universe was so hot and dense that light could not travel freely. It was like trying to see through thick fog. Think of this cosmic background as the ultimate baby picture of the universe. But here is where things get strange. This wall of ancient light creates a sphere around us, 46.5 billion light-years in every direction. We call this the observable universe, and it contains everything we can ever hope to see. But the word observable hides a terrifying truth. It does not mean this is all there is. It only means this is all we can detect. The actual universe, the real universe, likely extends far beyond this cosmic horizon. How far? We have no idea. Scientists compare our situation to being trapped in a cave with only a small window. You can see a patch of sky, but you cannot tell if there are mountains, oceans, or cities beyond your view. The cosmic horizon is our window, and everything beyond it remains hidden in absolute darkness. Some researchers believe the universe beyond our horizon looks much like what we see here. More galaxies, more stars, more planets spinning through the void. If this is true, then somewhere out there, copies of our solar system might exist. Copies of Earth, even copies of you, reading these exact words. But other scientists propose something far more unsettling. They suggest that beyond our cosmic sphere, the laws of physics might change completely. Space might curve back on itself like the surface of a balloon. Time could flow backward. Matter might behave in ways that would shatter our understanding of reality. The most haunting possibility is that there might be nothing at all beyond the edge. Not empty space, not darkness, but true nothingness. A void so complete that even the concept of beyond loses all meaning. We are about to explore each of these possibilities, traveling through theories that push the boundaries of human imagination. But first, we must understand something even more fundamental about the universe we think we know. Next, we discover that the edge itself might be moving away from us faster than anything should be able to travel. The edge of the observable universe is running away from us at an impossible speed. Every second, this cosmic boundary races outward at nearly 3 times the speed of light. This should be impossible, according to Einstein's theory of relativity, which states that nothing can move faster than light. Yet here we are, watching our own horizon sprint away into the darkness like a retreating tide. The secret lies in understanding what is actually expanding. It is not the galaxies themselves moving through space at these incredible speeds. Instead, space itself is stretching, carrying the galaxies along like boats on a flowing river. Imagine drawing dots on a balloon, then inflating it. The dots move apart not because they are racing across the rubber, but because the rubber itself is expanding beneath them. This expansion means that right now, as you read these words, the observable universe is growing larger. More space is coming into view. Light that was previously too far away to reach us is finally arriving after billions of years of travel. In essence, we are watching the universe reveal itself to us in real time. But here is the strange part. Even as more universe becomes visible, we are also losing sight of other regions forever. Objects near the edge of our cosmic horizon are being carried away so fast that their light will never reach us again. They are disappearing beyond a point of no return, vanishing into a realm we can never explore. Think of it like standing on a dock as a ship sails away. At first, you can see the entire vessel, then the hull disappears below the horizon. Finally, even the tallest mast vanishes from view. These distant galaxies are like that ship, slipping away into invisibility. This creates a troubling question. If the edge keeps expanding, why does the cosmic horizon exist at all? Why do we not see infinitely far in every direction? The answer lies in the age of the universe itself. Light has only had 13.8 billion years to travel since the Big Bang. No matter how fast space expands, light from beyond a certain distance simply has not had enough time to reach us yet. Scientists call this the particle horizon, and it represents the ultimate limit of what we can ever observe. Beyond this boundary lies the unobservable universe, a realm that might be infinite in size but remains forever hidden from our view. Recent measurements have revealed something even more unsettling about this expansion. The rate is not slowing down as we might expect from gravity pulling everything back together. Instead, it is accelerating. Some mysterious force, which scientists call dark energy, is pushing space apart faster and faster. This acceleration means that galaxies currently at the edge of our view will eventually disappear completely. Future civilizations, billions of years from now, will look up at a much emptier sky than we see today. But what drives this relentless expansion, and what lies beyond the boundary it creates? If space continues forever beyond our cosmic horizon, then everything that can happen must happen somewhere. This is the most mind-bending consequence of an infinite universe. In a realm with no boundaries, every possible arrangement of matter and energy must exist somewhere in the vast expanse. Every possible version of history, every possible version of you, every possible world that could ever be imagined. Mathematicians call this the principle of infinite probability. When you have unlimited space and unlimited time, even the most unlikely events become certainties. It is like having an infinite number of coin flips. Eventually, you will get every possible sequence of heads and tails, no matter how improbable. Picture this cosmic lottery in action. Somewhere beyond our horizon, there might be a galaxy identical to our Milky Way. In that galaxy, there could be a solar system just like ours, with a planet just like Earth. On that planet, in a city just like yours, someone who looks exactly like you might be reading these exact words at this very moment. But the infinite universe does not stop at simple copies. There would also be worlds where history unfolded differently. Versions of Earth where dinosaurs never went extinct. Civilizations that discovered space travel a million years ago. Planets where the laws of physics allow impossible things like magic or time travel. The mathematics behind this idea is surprisingly solid. In an infinite universe with finite building blocks, patterns must repeat. Think of typing random letters on a keyboard forever. Given enough time, you would eventually type every book ever written, every poem, every possible combination of words. The infinite universe works the same way, but with atoms instead of letters. Some scientists take this logic even further. They propose that if the universe is truly infinite, then there are not just copies of you out there, but infinite copies. An endless number of versions living slightly different lives, making different choices, experiencing different outcomes. This idea should fill you with wonder, but it also raises deeply troubling questions. If every possible version of your life exists somewhere, do your choices actually matter? If there is a version of you that makes every possible decision, then what makes your particular life special or meaningful? The infinite universe hypothesis also creates what philosophers call the Boltzmann brain paradox. In infinite space, random fluctuations of matter could spontaneously create a conscious brain floating in empty space. This brain would have false memories of entire life and world that never existed. Statistically, such random brains would vastly outnumber naturally evolved consciousness like ours. This leads to a disturbing conclusion. If the universe is infinite, you are more likely to be a disembodied brain floating in space with fake memories than a real person living on a real planet. The very act of reading this sentence could be nothing more than an illusion created by random quantum fluctuations. But perhaps the infinite universe is not the strangest possibility we face when we peer beyond the cosmic horizon. Next, we explore a theory that suggests our entire universe might be just one bubble floating in an even larger sea. Our entire universe might be nothing more than a single bubble in an infinite cosmic foam. This is the startling conclusion of eternal inflation theory, one of the most successful models in modern cosmology. According to this idea, the Big Bang that created our universe was not a unique event, but just one of countless explosions happening throughout an ever-expanding superspace. Picture blowing soap bubbles in your backyard. Each bubble is a complete, self-contained world with its own interior space. But all the bubbles exist within the larger space of your yard. In cosmic terms, our universe is one bubble, and the space between bubbles is something called the bulk, a higher dimensional realm, where the normal rules of physics might not apply. The process works like this. Quantum fluctuations in the bulk cause regions of space to suddenly inflate at incredible speeds. Each inflation event creates a new universe bubble with its own Big Bang, its own space, its own time, and possibly its own laws of physics. Meanwhile, the bulk itself continues expanding, creating room for even more universe bubbles to form. This means that right now, beyond our cosmic horizon, new universes are being born. Each one starts with its own version of the Big Bang and begins expanding into its own private space. Some of these universes might be similar to ours, with familiar particles and forces. Others could be radically different, with entirely alien physics that would seem impossible to us. Think of each universe bubble as having its own instruction manual for reality. In our universe, electrons have a specific charge and mass. Gravity works according to Einstein's equations. Light travels at a fixed speed, but in other bubbles, electrons might be 10 times heavier, gravity could repel instead of attract, or time might flow in multiple directions at once. The boundaries between these universe bubbles create some of the strangest regions imaginable. When two expanding bubbles collide, they create a collision zone where the laws of physics from both universes clash and merge. These cosmic crash sites might produce phenomena so bizarre that we lack words to describe them. Some researchers propose that we might actually detect evidence of other universe bubbles by looking for subtle patterns in our cosmic microwave background radiation. If our universe collided with another bubble in the distant past, it would leave a fingerprint in the ancient light that fills our space. But here is the truly unsettling part. If the bubble multiverse is real, then our observable universe represents an infinitesimally small fraction of what exists. Not only are we confined to one bubble among countless others, but we can only see a tiny portion of our own bubble. It is like being a microbe living on a soap bubble, able to see only a small patch of the surface, completely unaware of the vast foam surrounding you. The bubble multiverse also raises profound questions about the nature of existence itself. If infinite universes exist with every possible set of physical laws, then what makes our particular universe special? But even the bubble multiverse might be too simple to capture the full strangeness of reality. Every choice you have ever made has split the universe in two. This is the extraordinary claim of the many worlds interpretation of quantum mechanics, a theory that suggests reality branches into parallel universes every time a quantum event occurs. And quantum events happen everywhere, all the time, at the subatomic level, throughout the cosmos. Right now, as you read these words, countless quantum particles in your brain are making random decisions about which paths to take, which energy levels to occupy, which directions to spin. According to many worlds theory, each of these microscopic choices creates a new branch of reality. In one branch, the particle goes left. In another branch, it goes right. Both branches are equally real, and both versions of you continue existing in parallel. Picture reality as a vast tree with infinite branches. The trunk represents the beginning of the universe, and every quantum event creates a new fork in the branches. Over 13.8 billion years, this cosmic tree has grown so complex that it contains every possible version of history that could ever unfold. This means that somewhere in the quantum multiverse, there are branches where you made different choices. Versions of reality where you chose a different career, married a different person, or never existed at all. There are branches where dinosaurs evolved intelligence, where humans never left Africa, where Earth never formed in the first place. The mathematics behind this idea is surprisingly elegant. In quantum mechanics, particles exist in what scientists call superposition, meaning they can be in multiple states simultaneously until they are observed. Traditional quantum theory says that observation causes the particle to collapse into a single state. But many worlds theory suggests that observation actually splits reality so that every possible state of the particle exists in its own parallel universe. Think of flipping a quantum coin. In our everyday experience, the coin lands either heads or tails. But in the many worlds picture, reality splits into two branches, one where the coin shows heads and another where it shows tails. Both outcomes happen, just in different parallel universes. The truly staggering part is the rate at which these splits occur. Every quantum interaction in every atom, in every star, in every galaxy, creates new branches of reality. The number of parallel universes grows exponentially with each passing moment, creating a vast multiverse that contains more timelines than there are atoms in our observable universe. Some versions of many worlds theory suggest that these parallel universes exist beyond our cosmic horizon, layered like infinite sheets of paper in higher dimensional space. Others propose that they occupy the same space as our universe, but vibrate at different quantum frequencies, like radio stations broadcasting on different channels. But here is the haunting aspect of quantum many worlds. If every possible version of reality exists somewhere in the multiverse, then every possible version of suffering also exists. For every universe where you live a happy life, there might be countless others where you experience tragedy, pain, or loss. The quantum multiverse forces us to confront uncomfortable questions about the nature of identity and meaning in a reality where every possible version of everything exists simultaneously. Yet even this mind-bending concept might not capture the full scope of what lies beyond our cosmic boundary. Reality itself might be nothing more than pure mathematics, with physical matter as an illusion. This radical idea, proposed by cosmologist Max Tegmark, suggests that our universe is not made of particles, fields, or energy, but of mathematical relationships that somehow experience themselves as physical reality. If this theory is correct, then beyond our cosmic horizon lies not more space, but more mathematics. Think of the difference between a video game and the computer code that creates it. From inside the game, the characters see trees, buildings, and landscapes that feel completely real. But from outside, there is only code, numbers, equations, and logical operations. Tegmark proposes that we are like those video game characters, experiencing mathematical code as physical reality. This mathematical universe hypothesis goes far beyond the simple observation that mathematics describes the physical world accurately. It claims that mathematics does not just describe reality. Mathematics is reality. There is no difference between a mathematical structure and the physical universe it represents. Consider how this might work. Every electron in your body has properties like charge, mass, and spin. But what if these properties are not things the electron has, but mathematical relationships the electron is? What if an electron is simply a specific pattern of information, a particular solution to mathematical equations that govern quantum fields? If the mathematical universe theory is true, then beyond our observable boundary lies every possible mathematical structure that can exist. Universes based on different geometries, different numbers of dimensions, different logical systems altogether. There would be universes where space has 17 dimensions, where time splits into multiple streams, where the concept of causality works in reverse. Some of these mathematical universes would be so alien that conscious beings like us could never exist within them. Others might support forms of consciousness that we cannot even imagine. Think of mathematical structures where awareness emerges from pure number theory, where thoughts are geometric transformations, where memories are topological features of abstract space. The implications reach even deeper. If consciousness itself is a mathematical pattern, then every possible form of awareness must exist somewhere in the mathematical multiverse. There would be minds that experience reality as music, others that think in colors that do not exist in our spectrum, and perhaps some that perceive all of mathematics simultaneously. But this theory also leads to a profound puzzle about existence itself. If every possible mathematical structure exists, then why do we find ourselves in this particular one? Why do we experience a universe with 3 spatial dimensions, 1 time dimension, and the specific physical constants that allow stars and planets to form? Some researchers propose that most mathematical structures are too simple or too chaotic to support complex consciousness. We exist in this particular universe not because it is special, but because it is one of the few mathematical structures complex enough to contain beings capable of asking these questions. The mathematical universe forces us to reconsider everything we think we know about the nature of existence, reality, and our place within it. But perhaps the most unsettling possibility is that there might be nothing at all beyond our cosmic horizon. What if our universe is all that exists, floating alone in an infinite void of absolute nothingness? This possibility haunts cosmologists who study the shape and size of space itself. While most scientists assume the universe extends far beyond what we can observe, there is another scenario that changes everything. Our cosmos might be a finite island of existence surrounded by pure emptiness. Picture a single soap bubble floating in a vast, empty warehouse. The bubble contains all the air, all the matter, all the energy that exists anywhere. Outside the bubble is not different air or different matter, but absolute vacuum. Not the kind of vacuum we find in space, which still contains quantum fields and virtual particles, but true nothingness. No space, no time, no possibility of anything existing. In this scenario, the edge of our universe would be the most terrifying boundary imaginable. It would not be a place you could visit or cross, because there would be no there to go to. The concept of beyond would become meaningless. It would be like asking what is north of the North Pole, or what happened before the beginning of time. The mathematics of general relativity allows for such finite universes. Space could curve back on itself like the surface of a sphere, creating a cosmos with a definite size and boundary. If you could somehow travel fast enough and far enough in one direction, you would eventually return to your starting point, just as a ship sailing east on Earth eventually comes back from the west. But unlike the surface of a sphere, which is embedded in 3-dimensional space, our curved universe would not be embedded in anything. There would be no higher dimensional space for it to curve through. The universe would be intrinsically finite, a complete and self-contained reality with edges that touch nothing. Some versions of this idea propose that our universe is shaped like a donut, a pretzel, or even more exotic geometric forms. Each shape would create different patterns in the cosmic microwave background radiation, giving us potential ways to test whether space truly has boundaries. The psychological impact of living in a finite universe would be profound. Instead of being tiny specks in an infinite cosmos, we would be inhabitants of the only island of existence that has ever been or ever could be. Every atom, every star, every galaxy would be precious beyond measure. because there would be literally nothing else anywhere. This finite universe scenario also raises deep questions about what caused it to exist. If there is nothing outside our cosmic bubble, then what brought it into being? What determines its size and shape? Why does this particular finite universe exist rather than a different one, or none at all? The idea of cosmic loneliness, of being the only pocket of existence in an infinite void, might be more unsettling than any of the multiverse theories we have explored. But there is one possibility even stranger than finite isolation: that space itself might be curved in ways that create impossible connections. When you look toward the edge of the observable universe, you might actually be looking at yourself. This mind-bending possibility emerges from the strange geometry of curved space, where the universe could be shaped like a hall of mirrors that creates infinite reflections of the same finite space. If this is true, then the most distant galaxies we observe might actually be nearby galaxies, seen from impossible angles, their light having traveled the long way around a curved cosmos. Imagine living inside a house where every wall is a perfect mirror. You would see countless copies of yourself and your furniture, stretching into the distance. But these would not be separate rooms or separate people. They would all be reflections of the same single room, the same single you. The cosmic mirror universe works the same way, but with space itself acting as the reflecting surface. In this scenario, the universe has a finite size but no edges. Space curves back on itself in complex ways that mathematicians call non-trivial topology. Think of an ant walking on the surface of a donut. The ant can travel forever without ever reaching a boundary, but it will eventually return to places it has been before because the surface has a finite area. If our universe has this kind of twisted geometry, then looking in opposite directions in the sky might actually show us the same regions of space from different perspectives. The cosmic microwave background radiation we observe in the north could be the same radiation we see in the south, just viewed from a different angle after its light traveled around the curved universe. Scientists are actively searching for evidence of this cosmic mirror effect. They look for matching patterns in the temperature fluctuations of the cosmic microwave background that appear in different parts of the sky. If they find such matches, it would prove that space curves back on itself and that we live in a hall of cosmic mirrors. The discovery of cosmic mirroring would revolutionize our understanding of the universe's size and structure. Instead of being 13.8 billion light-years across, the actual universe might be much smaller, perhaps only a few billion light-years in circumference. Every distant galaxy, every far-off quasar, every remote corner of space we observe would actually be relatively nearby, just seen through the funhouse geometry of curved space-time. But this creates a disturbing puzzle about observation and reality. If we can see the same galaxy from multiple directions as light travels different paths around the curved universe, which view shows us the galaxy as it really is? Are we seeing it in its current state, or as it was at different times in the past as light took shorter or longer routes to reach us? The cosmic mirror universe also raises questions about uniqueness and identity. If space curves back on itself, then every point in the universe might be connected to every other point through multiple paths. The distinction between here and there, between near and far, would become fundamentally meaningless. Yet perhaps the most profound mystery lies not in the geometry of space, but in the nature of nothingness itself. What does it mean for nothing to exist, and how can nothing be something that exists beyond our universe? This question strikes at the heart of one of philosophy's deepest puzzles. When scientists talk about what lies beyond the observable universe, they often use the word nothing as if it describes a place or a thing. But true nothingness cannot be a place, because places require space. It cannot be a thing, because things require existence. True nothingness is the absence of absence itself. Think about the difference between an empty box and no box at all. The empty box still contains space, still has dimensions, still exists as a container. But true nothingness would be the absence of even the box itself. No container, no space to contain, no possibility of containment. It is not darkness, because darkness implies the absence of light in a place where light could exist. It is not silence, because silence implies the absence of sound in a place where sound could occur. Philosophers have struggled with this concept for thousands of years. The ancient Greeks asked whether nothing could be something, and whether something could come from nothing. They realized that even thinking about nothing makes it something, because it becomes an object of thought. The very act of imagining nothingness gives it a kind of existence in our minds. Modern physics has complicated this picture even further. Quantum mechanics tells us that what we call empty space is actually filled with virtual particles popping in and out of existence, zero-point energy fluctuations, and quantum fields that permeate every point in space. The vacuum of space is not nothing. It is a very active something that just happens to be invisible. But beyond the edge of our universe, we might encounter a different kind of nothing. Not the quantum vacuum of empty space, but the absence of space itself. No dimensions, no fields, no possibility of anything existing or happening. This is the kind of nothing that makes the question, what is beyond the universe, potentially meaningless, like asking what color the number 7 is, or whether silence has a taste. Some philosophers argue that true nothingness is impossible because existence is the fundamental nature of reality. In this view, something has always existed and always will exist. The question becomes not whether anything exists beyond our universe, but what kind of something it might be. Others propose that nothingness is not only possible, but inevitable. They suggest that existence is the unusual state, and that most of reality consists of the absence of reality. In this framework, our universe is a rare bubble of something floating in an infinite ocean of nothing. The debate touches on the deepest questions of existence. Why is there something rather than nothing? What makes existence possible? Is the absence of everything a coherent concept? Or does it collapse under its own logical contradictions? These questions become more than philosophical curiosities when we consider that the answer might determine the ultimate fate of everything we know and love. But perhaps the most important question is not what lies beyond the universe, but what the search for answers reveals about the nature of human curiosity itself. Every answer we discover about what lies beyond the universe reveals how much more we do not know. This is the fundamental paradox of cosmic exploration. The more we learn about the nature of space, time, and reality, the more questions emerge that we never thought to ask before. Each breakthrough in physics opens new mysteries that dwarf the problems we thought we were solving. Consider how our understanding has evolved over just the past century. When Einstein developed general relativity, scientists thought the universe was static and eternal. Then Hubble discovered that space is expanding, forcing us to confront the reality of a cosmic beginning. Later, we found dark matter and dark energy, revealing that ordinary matter makes up only 5% of what exists. Now we face the possibility that our entire observable universe might be one tiny fragment of something unimaginably larger. Each discovery has pushed the horizon of knowledge further away, like chasing a sunset that retreats as fast as we approach it. We thought galaxies were the largest structures in the universe, until we found galaxy clusters. We thought galaxy clusters were the largest structures, until we found superclusters and cosmic filaments. We thought our universe was everything, until theories suggested multiverses containing infinite universes. The pattern reveals something profound about the relationship between human consciousness and cosmic reality. We are biological beings that evolved on a small planet, with brains designed to understand medium-sized objects moving at medium speeds in our immediate environment. Yet somehow, these same brains can contemplate infinity, comprehend quantum mechanics, and imagine realities beyond all possible observation. Think of the mathematical tools we use to explore the edge of existence: differential equations that describe the curvature of spacetime, quantum field theories that predict the behavior of virtual particles, statistical mechanics that explains the arrow of time. These are not concepts that natural selection designed us to understand, yet we do understand them, at least partially. This suggests something remarkable about the nature of intelligence itself. Consciousness might not be a biological accident, but a fundamental feature of reality that allows the universe to understand itself. We are not just observers of cosmic mysteries. We are the universe becoming aware of its own existence. But our role as cosmic detectives comes with deep responsibilities. Every question we ask about what lies beyond the observable universe is also a question about what it means to be conscious, rational beings in a reality that might be far stranger than we can imagine. The search for knowledge has always been humanity's greatest adventure. It has driven us to build telescopes that peer deeper into space than any eye can see, to develop mathematics that describes realities no mind can fully picture, to ask questions that might not have answers. As we stand at the edge of the observable universe, looking out into the unknown, we are also looking into ourselves. The mysteries that lie beyond our cosmic horizon are mirrors that reflect the mystery of consciousness itself. The journey to understand what exists beyond the edge of everything has only just begun. What if everything beyond our cosmic horizon is simply more computer code running on an alien supercomputer? This is not science fiction speculation, but a serious scientific hypothesis proposed by philosopher Nick Bostrom and embraced by physicists like Neil deGrasse Tyson. The simulation theory suggests that our entire universe, including everything we think lies beyond it, might be an artificial reality created by some advanced civilization. Think about how quickly our own computer simulations have evolved. 50 years ago, the most advanced video games were simple dots moving across a screen. Today, we create virtual worlds so realistic that players can spend entire lifetimes exploring digital landscapes that feel completely real. If this trend continues, future civilizations might develop computers powerful enough to simulate entire universes, complete with billions of conscious beings who never realize they are living inside a program. The mathematics behind this idea are surprisingly compelling. If advanced civilizations can create realistic universe simulations, they would likely run many of them for research, entertainment, or educational purposes. This means there would be countless simulated universes for every real one. Statistically speaking, any conscious being is far more likely to exist inside a simulation than in base reality. The implications reach far beyond our cosmic horizon. If we are simulated beings, then the edge of our observable universe might simply be the boundary of the computer program running our reality. Beyond that edge might not be more space or parallel universes, but the alien equivalent of computer memory, processing cores, and cooling systems. Evidence for the simulation hypothesis might already exist in the fundamental structure of reality. Quantum mechanics behaves remarkably like the optimization tricks programmers use to save computing power. Particles exist in undefined states until observed, just like video game landscapes that only render in detail when a player looks at them. The universe has a maximum speed limit, just like computers have maximum processing speeds. Space and time appear to be quantized at the smallest scales, just like digital information is broken into discrete bits. Some researchers propose that we might detect glitches in our simulated reality by looking for inconsistencies in physical laws or mathematical constants. Others suggest that the cosmic microwave background radiation might contain hidden messages from our programmers, like digital signatures embedded in the code. But the simulation hypothesis creates a disturbing recursive problem. If we are simulated beings who develop our own universe simulations, then the beings in our simulations might also develop simulations, creating an infinite nested hierarchy of artificial realities. Each level would believe their simulated universe represents the full scope of existence, never knowing that they are characters in someone else's digital world. The question becomes, how many levels deep might this simulation stack go? Are we first-level simulations run by biological beings? Or are we simulations of simulations of simulations, nested so deeply that the original creators are lost in the recursive layers? If the simulation hypothesis is true, then the search for what lies beyond our universe becomes a search for the hardware running our reality. But perhaps the most unsettling possibility is that space itself might be an illusion hiding something far more fundamental. Everything you think exists in three-dimensional space might actually be encoded on a two-dimensional surface at the edge of the universe. This revolutionary idea, called the holographic principle, suggests that all the information describing our three-dimensional reality is actually stored on a distant two-dimensional boundary, like a cosmic hard drive that projects reality into our local space. If this is true, then beyond our observable universe lies not more space, but the surface where our entire existence is written in quantum code. Picture a hologram on a credit card. The image appears three-dimensional, but all the information creating that illusion is actually encoded on the flat surface of the card. The holographic principle proposes that our universe works the same way. Every particle, every force, every event happening in our three-dimensional space is actually information encoded on a two-dimensional boundary that we can never reach or observe directly. The mathematics behind this idea emerged from studying black holes. Physicist Jacob Bekenstein discovered that the amount of information a black hole can contain is proportional to the area of its surface, not its volume. This was shocking because three-dimensional objects should store information throughout their volume, not just on their surface. Yet black holes behave as if they are fundamentally two-dimensional entities that only appear three-dimensional from our perspective. Stephen Hawking extended this insight when he discovered that black holes emit radiation. The information that falls into a black hole must somehow be preserved in the radiation that comes out, but in a scrambled form that makes it impossible to reconstruct what fell in. This suggests that the black hole's surface acts like a holographic screen that processes and stores information about everything that crosses the event horizon. Physicists Juan Maldacena then proved that this holographic principle applies to entire universes, not just black holes. In his mathematical framework, our three-dimensional space with gravity is equivalent to a two-dimensional surface without gravity. These are not just similar or analogous. They are the same thing described in different ways, like looking at the same object from different angles. If the holographic principle is correct, then the edge of our observable universe might be the location of this cosmic holographic screen. Everything we experience as three-dimensional reality would actually be a projection from information encoded on that distant boundary. Space, matter, energy, and even time itself would be emergent phenomena arising from deeper two-dimensional patterns. This creates a profound puzzle about the nature of distance and separation. If all the information describing you is actually encoded on a faraway surface, then in what sense do you exist here rather than there? The distinction between inside and outside, between local and remote, becomes fundamentally meaningless. The holographic principle also suggests that reality has far less information content than it appears. Instead of every point in three-dimensional space requiring its own description, all of that information can be compressed onto a two-dimensional surface with no loss of detail. But if space itself is just a holographic illusion, what does that tell us about the other mysteries we encounter when we push beyond conventional reality? The interior of every black hole might contain an entire universe larger than our own. This mind-bending possibility emerges from the mathematics of extreme gravity and the strange behavior of space and time near the event horizon. When matter collapses to form a black hole, the intense gravitational field creates regions where the normal rules of physics break down completely. Inside that breakdown, entirely new universes might be born. Picture what happens when a massive star runs out of fuel and collapses under its own gravity. The core shrinks so rapidly that it creates a gravitational field strong enough to trap light itself. From the outside, we see an event horizon, a boundary beyond which nothing can escape. But from the inside, something far stranger might be happening. According to some theories, the collapsing matter does not form a simple point of infinite density called a singularity. Instead, the extreme conditions trigger a kind of reverse Big Bang, creating an expanding universe on the other side of the event horizon. This new universe would be completely disconnected from ours, with its own space, its own time, and its own physical laws. Think of it like a cosmic birth process. Every time a black hole forms in our universe, It gives birth to a baby universe that grows inside the event horizon. These baby universes would be invisible to us because no information can travel back across the event horizon to tell us what is happening inside. From our perspective, the black hole appears to be a dead end where matter and energy disappear forever. But from inside, it might be the beginning of an entirely new cosmos. The mathematics suggest that these black hole universes could be enormous, potentially containing billions of galaxies and lasting for trillions of years. The event horizon that appears tiny from our perspective might enclose a space larger than our entire observable universe. Time dilation effects near the black hole mean that billions of years could pass inside while only seconds tick by in our external time frame. This creates a nested hierarchy of universes within universes. If black holes in our universe create baby universes, then black holes in those baby universes might create their own offspring, leading to an infinite family tree of cosmic generations. Each universe would spawn countless children, and each of those children would spawn countless more. The implications for what lies beyond our cosmic horizon are staggering. Instead of asking what exists outside our universe, we might need to ask which generation of the cosmic family tree we belong to. Are we a first-generation universe that formed naturally, or are we living inside a black hole created by some parent universe we can never observe? Some researchers propose that our Big Bang itself might have been the interior of a black hole that formed in a higher-level universe. The rapid expansion we observe might be the natural behavior of space and time inside an event horizon, making our entire observable cosmos just the interior of one black hole among countless others. But the true nature of what lies beyond our universe might depend on something even more fundamental than space and gravity. Time itself might flow backward beyond the edge of our universe, creating regions where effect precedes cause and the future determines the past. This possibility emerges from the deepest mysteries of thermodynamics and the strange fact that the laws of physics are almost entirely symmetric in time. Most fundamental equations work equally well, whether time flows forward or backward, yet we experience a universe where time has a clear direction, from past to future, from order to disorder, from cause to effect. The arrow of time that we experience comes from the second law of thermodynamics, which states that entropy, or disorder, always increases in isolated systems. Think of a drop of food coloring spreading through a glass of water. The coloring always spreads from concentrated to dispersed, never the reverse. This gives us our sense of temporal direction, our feeling that some moments come before others. But this raises a profound question. Why did our universe begin in a state of low entropy? The Big Bang started with matter and energy arranged in an extremely organized configuration that has been becoming more disordered ever since. This initial state was so improbable that some cosmologists compare it to finding a billion coin flips that all came up heads by pure chance. Beyond our cosmic horizon, the arrow of time might point in the opposite direction. In these regions, entropy would decrease rather than increase. Broken objects would spontaneously repair themselves. Scattered particles would gather into organized structures. Dead stars would come back to life by absorbing their own radiation. Picture walking through a cosmic boundary where the arrow of time reverses. On one side, you would see normal physics with clear cause and effect relationships. But as you cross the boundary, you would enter a realm where effects happen before their causes, where events flow from future to past, where memory works in reverse and prediction becomes a record of what has already happened. The mathematics of such time-reversed regions are consistent with general relativity and quantum mechanics. These zones would appear perfectly normal to any inhabitants living within them, because their consciousness and memory would also operate in reverse temporal order. They would experience their version of cause and effect as natural and logical, just as we experience ours. Some cosmological models propose that our universe exists at the boundary between two vast regions with opposite arrows of time. Our Big Bang might represent the point where two time streams meet, creating a zone where entropy can decrease in both temporal directions simultaneously. This would make our observable universe a kind of temporal estuary, where different flows of time converge and mix. If regions with reverse time exist beyond our horizon, they would be fundamentally invisible to us. Light traveling from those regions would appear to us as if it were traveling into the past, creating logical paradoxes that might prevent any information from crossing the temporal boundary. The arrow of time might not be a universal feature of reality, but a local property of our particular region of space. Yet perhaps time itself is just another illusion, hiding an even deeper truth about the nature of existence. In the far future, our universe will expand into a cold, dark wasteland where even atoms decay into nothingness. But beyond our cosmic boundary, this death might be the seed of infinite rebirth. This is the ultimate fate predicted by thermodynamics. Heat death, the final state where entropy reaches its maximum and all energy becomes evenly distributed throughout space. Stars will burn out, black holes will evaporate, and even protons will decay into elementary particles. The universe will become a vast, empty space, filled only with photons and neutrinos drifting apart at ever-increasing distances. Think of heat death as the cosmic equivalent of a cup of hot coffee cooling to room temperature. Initially, there are differences in temperature that allow energy to flow and work to be done. But eventually, everything reaches thermal equilibrium, and no more work is possible. The universe becomes a uniform sea of low-energy particles, with no structure, no information, and no possibility of change. But this apocalyptic scenario might only apply to our local region of space. Beyond our cosmic horizon, entirely different thermal environments might exist. Some regions could be in earlier stages of cosmic evolution, with young stars still forming and galaxies still growing. Others might be in later stages, approaching their own heat death. Still others might operate under completely different thermodynamic rules. The process of heat death might take an almost unimaginable amount of time. Current estimates suggest that the last stars will burn out in about 100 trillion years. Black holes will take much longer to evaporate through Hawking radiation. The most massive black holes might persist for 10 to the 100th power years before finally disappearing into elementary particles. Yet even after heat death, quantum mechanics suggests that the universe might not remain dead forever. In an infinite expanse of time, random quantum fluctuations could spontaneously create new structures, new complexities, even new forms of life. Given enough time, these fluctuations might rebuild entire universes through pure chance. Some cosmologists propose that heat death represents not an ending but a transition. The maximum entropy state might be unstable over cosmic timescales, eventually collapsing or transforming into new phases of cosmic evolution. What appears to be the end of everything might actually be the preparation for a new beginning. Beyond our observable boundary, some regions might have already undergone heat death and rebirth multiple times. They could be in their second, third, or millionth cycle of cosmic evolution, having learned to transcend thermodynamic limitations through mechanisms we cannot imagine. The heat death scenario also raises profound questions about the purpose and meaning of existence in a finite universe. If everything we build, everything we create, everything we discover will eventually be erased by cosmic expansion and entropy, then what gives our lives significance in the face of such ultimate futility? Perhaps the answer lies not in defeating heat death, but in understanding that our brief moment of cosmic organization represents something precious and unprecedented in the vast history of space and time. But what if the boundaries between death and rebirth, between ending and beginning, are not as clear as they appear? Right now, there is a tiny but real chance that you could spontaneously quantum tunnel through the edge of space itself and appear in a completely different universe. This extraordinary possibility comes from quantum mechanics, where particles can sometimes pass through barriers that should be impossible to cross according to classical physics. The mathematics show that even large objects, including human beings, have a non-zero probability of tunneling through any barrier, no matter how thick or impenetrable it appears. Picture throwing a ball at a brick wall. In classical physics, the ball bounces back every single time. But in quantum mechanics, there is always a tiny chance that the ball will pass through the wall as if it were not there. This probability becomes vanishingly small for large objects like balls, but it never becomes exactly zero. The same principle might apply to the boundaries of space itself. If our universe has edges or boundaries separating it from other regions of reality, then quantum tunneling could allow matter and energy to cross those boundaries spontaneously. You could theoretically tunnel from inside our cosmic horizon to whatever lies beyond it. The probability of such large-scale tunneling is extraordinarily small. The chance of a human spontaneously tunneling through the cosmic boundary would be roughly 1 in 10 to the power of 10 to the power of 50. This number is so large that it defies human comprehension. You would need to wait far longer than the age of the universe for such an event to have even a remote chance of occurring. But in an infinite multiverse with infinite time, even impossibly unlikely events become inevitable. Somewhere in the vast expanse of space and time, copies of you are constantly tunneling between different regions of reality, exploring universes with different physical laws, different histories, different possibilities. The process would be instantaneous and undetectable from our perspective. One moment you would be here, reading these words in our familiar universe. The next moment, a quantum-tunneled version of you would exist in a completely alien reality, potentially retaining all your memories, but finding yourself in a world where the laws of physics work differently. Some interpretations of quantum mechanics suggest that this tunneling happens continuously at the subatomic level. Every quantum particle in your body might be constantly tunneling between different branches of the multiverse, with most tunneling events being so small that they go unnoticed. But occasionally, larger tunneling events might occur, shifting entire molecules or even larger structures between different realities. The implications extend beyond personal transportation between universes. Quantum tunneling might allow information to leak between different regions of the cosmic multiverse. The random quantum fluctuations we observe in empty space might actually be signals from neighboring universes, faint whispers of alien realities bleeding through the quantum foam. If quantum tunneling can cross cosmic boundaries, then the edge of our universe might not be a permanent barrier but a permeable membrane. Matter, energy, and information might constantly flow between our reality and whatever lies beyond, creating a cosmic ecosystem where different universes exchange resources and influence each other's evolution. But perhaps the most remarkable possibility is that our universe itself might be the product of such cosmic tunneling. What if our Big Bang was not the beginning of everything, but simply the latest explosion in an infinite cycle of cosmic death and rebirth that has been repeating forever? This is the revolutionary idea behind cyclic cosmology, which suggests that the universe expands, ages, dies, and then rebounds into a new Big Bang in an eternal loop. If this theory is correct, then beyond our cosmic horizon might lie the remnants of previous cosmic cycles, the seeds of future universes, and the machinery that drives the endless wheel of cosmic reincarnation. Picture the universe as a vast cosmic heart that beats once every trillion years. During each beat, space expands from a tiny point, grows to enormous size, then contracts back down to a point, before exploding outward again. We are currently living during the expansion phase of one such cosmic heartbeat, but countless previous beats have come before us, and countless more will follow. The mathematics of this cyclic model solves several puzzles that plague standard Big Bang theory. Instead of asking what caused the Big Bang or what came before it, cyclic cosmology simply states that there was a previous universe that collapsed and rebounded. The incredible fine-tuning required for our universe to support stars, planets, and life becomes less mysterious if the cosmos has had infinite opportunities to try different combinations of physical constants. In the cyclic model, the edge of our observable universe might contain traces of previous cosmic cycles. Ancient gravitational waves from earlier Big Bangs might still be rippling through space, carrying information about universes that existed trillions of years ago. The cosmic microwave background radiation might contain subtle patterns that reveal the structure of the universe that came before ours. Each cycle would be slightly different from the last. Quantum fluctuations during the collapse and rebound phases would ensure that no two cosmic cycles are exactly identical. Some cycles might produce universes filled with stars and galaxies much like ours. Others might create cosmos dominated by black holes or filled with exotic forms of matter that we cannot imagine. The transition between cycles would be the most extraordinary event in all of physics. As space contracts during the collapse phase, galaxies would rush together, stars would merge, and eventually all matter and energy would be compressed into a region smaller than an atomic nucleus. At this moment of maximum compression, quantum effects would become so strong that space and time themselves might break down and reform according to different rules. Think of this cosmic recycling process as the ultimate form of sustainability. Nothing is ever truly lost or wasted. Every atom that has ever existed, every thought that has ever been thought, every star that has ever shined, gets compressed, processed, and reborn in the next cosmic cycle. Death becomes birth, ending becomes beginning, and the universe achieves a kind of immortality through endless transformation. But if we live in a cyclic universe, this raises profound questions about identity and meaning. Are we truly unique individuals? Or are we variations on themes that have played out billions of times in previous cosmic cycles? The answer might depend on forces operating in dimensions we cannot see. Right next to you, invisible and untouchable, might be entire universes existing in dimensions your mind cannot picture. This is not science fiction speculation, but a serious possibility emerging from string theory and higher dimensional physics. The mathematics suggest that our familiar three-dimensional space might be just a thin slice of a much larger reality containing 6, 7, or even 11 dimensions of space, each potentially harboring its own form of existence. Think of how a two-dimensional being living on a piece of paper would perceive our three-dimensional world. They might see our fingers as mysterious circles that appear and disappear as we move our hands above and below their paper universe. In the same way, we might be surrounded by higher dimensional beings whose presence we can only detect as strange shadows and influences in our three-dimensional space. The extra dimensions might be curled up so tightly that they are invisible at normal scales, like a garden hose that appears one-dimensional from a distance but reveals its circular cross-section when viewed up close. These compact dimensions could be smaller than atoms, yet they might determine the fundamental properties of particles and forces in our observable universe. String theory requires these extra dimensions to exist for its mathematics to work correctly. In this framework, what we think of as particles are actually tiny vibrating strings moving through all 11 dimensions simultaneously. The different vibration patterns in the extra dimensions determine whether a string appears to us as an electron, a photon, or any other type of particle. But some versions of higher dimensional theory suggest that entire universes might exist in parallel dimensions that are large rather than small. These universe-sized extra dimensions would be completely separate from ours, with their own matter, energy, and possibly their own forms of life. We would be invisible to them, and they would be invisible to us, because we are confined to different dimensional slices of the same higher dimensional space. The boundary of our universe might not be an edge in three-dimensional space, but a limitation of how far we can reach into the higher dimensions. Beyond our cosmic horizon might lie not more three-dimensional space, but access to these hidden dimensions, where entirely different forms of reality operate according to geometric principles we cannot visualize. Gravity might be the one force that can leak between dimensions, which could explain why it is so much weaker than electromagnetism and the nuclear forces. Some gravitons might be escaping from our three-dimensional space into the extra dimensions, carrying energy away to universes we can never see or visit. Scientists are searching for evidence of extra dimensions by looking for tiny deviations in gravitational behavior at very small scales. If gravity becomes stronger than expected when measured over distances smaller than a millimeter, it might indicate that gravitons are being confined to fewer dimensions at short ranges. The discovery of large extra dimensions would revolutionize our understanding of what lies beyond the observable universe. Instead of asking what exists outside our space, we would need to ask what exists outside our dimensional slice of a much larger, higher dimensional reality. But perhaps the strangest possibility is that consciousness itself plays a fundamental role in determining what dimensions become real. The simple act of observing the universe might be creating the very reality that extends beyond our cosmic horizon. This mind-bending possibility emerges from quantum mechanics, where the act of measurement appears to transform possibilities into actualities. In the quantum world, particles exist in superposition, simultaneously occupying multiple states until the moment they are observed. Then the wave function collapses, and reality selects one specific outcome from all the possibilities. But what if this observer effect operates not just on individual particles, but on the structure of space and time itself? What if the universe beyond our horizon exists in quantum superposition, containing every possible configuration simultaneously, until the moment we observe it and force it to choose a specific reality? Think of reality as an infinite garden of forking paths, where every possible universe exists in quantum superposition until conscious observation collapses the wave function and selects one particular path. The edge of our observable universe might represent the boundary between the collapsed, definite reality we have observed and the uncollapsed, probabilistic reality that exists in superposition beyond our sight. This interpretation suggests that the universe has been growing and crystallizing into definite form as consciousness has evolved and expanded its reach. Early in cosmic history, when there were no observers, most of reality might have existed in pure superposition. As stars formed and eventually gave birth to planets with conscious life, those observers began collapsing larger and larger regions of space into definite states. The implications are staggering. Every time astronomers point a telescope toward a previously unobserved region of space, they might be literally creating that part of the universe by forcing it to choose specific properties. The galaxies they discover might not have had definite positions, masses, or ages until the moment of observation collapsed their quantum wave functions. Some interpretations of quantum mechanics suggest that consciousness is not just observing reality, but actively participating in its creation. The universe might be engaged in an ongoing dialogue with conscious observers, where each act of observation reshapes the possibilities for what can exist beyond the current boundary of knowledge. But this raises profound questions about the relationship between mind and cosmos. If observation creates reality, then what existed before conscious beings evolve? Did the universe exist in pure potential until the first conscious observer collapsed its wave function? Or does consciousness itself exist in quantum superposition, with every possible observer simultaneously creating every possible universe? The observer effect might also work in reverse. Just as our observations might be creating the reality beyond our horizon, observers in other regions of the multiverse might be creating our reality through their observations. We might be the product of alien consciousness collapsing quantum wave functions in their observable universe. This creates a cosmic feedback loop where observers create reality, and reality creates observers. And the boundary between mind and matter becomes fundamentally meaningless. The edge of our universe might not be a place at all, but a process of ongoing creation driven by the mysterious interaction between consciousness and quantum possibility. But what if consciousness itself is not just an observer of reality, but the fundamental substance from which all existence emerges? What if consciousness is not something that emerged from matter, but the fundamental fabric from which matter, space, and time themselves are woven? This revolutionary idea, called Panpsychism, suggests that awareness is a basic feature of reality, like mass or electric charge. Every particle, every atom, every quantum field might possess some primitive form of experience. The complex consciousness you feel right now would be built from countless tiny conscious moments happening throughout your brain and body. Picture consciousness as a spectrum rather than an on-off switch. At one end, you have the rich, complex awareness of human beings with their thoughts, emotions, and memories. At the other end, you might have the simple, minimal awareness of an electron responding to electromagnetic fields. Between these extremes lies every possible gradation of consciousness, from the collective awareness of ant colonies to the alien consciousness of entire ecosystems. If consciousness is fundamental, then the boundary of our observable universe might not be a limit of space or matter, but a limit of the cosmic mind that encompasses all existence. Beyond our horizon might lie regions of reality where consciousness operates according to completely different principles, where awareness takes forms we cannot imagine or understand. Some versions of panpsychist theory suggest that the universe itself is a single, vast conscious entity experiencing reality from countless perspectives simultaneously. Every human mind, every animal brain, every possible form of awareness would be like neurons in a cosmic brain that spans all of space and time. Our individual consciousness would be temporary patterns in this universal mind, like waves on an infinite ocean. The mathematics of quantum mechanics might actually describe the behavior of this cosmic consciousness rather than unconscious matter. What we call wave function collapse might be moments when the universal mind makes decisions about how reality should unfold. The uncertainty principle might reflect the inherent creativity and spontaneity of consciousness at the fundamental level. If consciousness permeates all of reality, then the regions beyond our cosmic horizon might be inhabited by forms of awareness that operate on scales we cannot comprehend. Galactic consciousness spanning millions of stars. Dimensional consciousness existing across multiple universes simultaneously. Temporal consciousness that experiences past, present, and future as a single eternal moment. These cosmic minds might be as far beyond human awareness as human consciousness is beyond the simple responsiveness of bacteria. They might be engaged in thoughts and experiences that take millions of years to complete, pursuing goals and purposes that encompass the evolution of entire cosmic structures. The discovery that consciousness is fundamental would transform our understanding of what lies beyond the observable universe. Instead of asking whether there is more matter and energy out there, we would need to ask what kinds of awareness exist in those distant realms and how they experience reality. But perhaps the most profound implication is that your consciousness, the very awareness reading these words right now, is not separate from the universe, but is the universe experiencing itself subjectively through your particular perspective. This raises the ultimate question: what does it mean to be a conscious being in a conscious cosmos, and how does individual awareness relate to the infinite mind that encompasses all existence? What if our universe created itself by sending information backward through time to cause its own beginning? This is the cosmic version of the Bootstrap paradox, a logical puzzle where an effect becomes its own cause, creating a closed loop of causation that has no true beginning or end. In cosmology, this paradox might explain how our universe could exist without requiring anything external to create it. Think of the classic example. A time traveler goes back and gives Shakespeare a copy of Hamlet, which Shakespeare then publishes as his own work. Years later, the time traveler finds the play in a bookstore and takes it back to give to Shakespeare. Where did Hamlet actually come from? The information seems to exist without ever being created by anyone. The universe might work the same way. Quantum mechanics allows information to propagate backward through time under certain conditions. If our universe generates enough complexity and consciousness to eventually develop time travel or backward causation, then information from our far future might be responsible for fine-tuning the initial conditions that made our existence possible in the first place. Picture this cosmic feedback loop. Billions of years in the future, advanced civilizations discover how to send information backward through the quantum foam of space-time. They use this capability to adjust the fundamental constants and initial conditions of the Big Bang, ensuring that the universe evolves in exactly the way necessary to produce those same civilizations. The universe becomes its own creator, engineering its own existence through temporal loops that span cosmic history. This bootstrap mechanism might explain the incredible fine-tuning we observe in physical constants. Why is the strength of gravity precisely the right value to allow stars to form? Why do the nuclear forces have exactly the properties needed for heavy elements to exist? Instead of requiring external design or infinite multiverse selection, these values might be the result of our universe's future influencing its own past. The regions beyond our cosmic horizon might be where these temporal loops originate and terminate. Information traveling backward through time might emerge from future universe states that exist outside our current observable boundary. The edge of our cosmos might not be a spatial boundary, but a temporal one, where cause and effect relationships become circular and self-sustaining. But the Bootstrap paradox creates deep philosophical problems about the nature of existence and causation. If the universe creates itself, then what provides the initial information or energy for the process to begin? How can something be its own cause without having some prior existence to enable the causal loop? Some physicists propose that the Bootstrap universe exists in a state of necessary existence, where the self-creating loops are so logically tight that reality has no choice but to exist in exactly this configuration. The universe would be like a mathematical theorem that proves itself, a self-evident truth that cannot be otherwise. If our cosmos is indeed a Bootstrap universe, then the search for what lies beyond our horizon becomes a search for the mechanisms of cosmic self-creation. But perhaps the deepest mystery is not how the universe creates itself, but what makes existence possible at all. Everything you think is real matter, energy, space, and time, might be nothing more than patterns of information processing in a cosmic computational system. This radical idea, called digital physics, suggests that the universe is fundamentally made of information rather than physical substances. Every particle, every force, every quantum field would be a pattern of data being processed by the ultimate computer, reality itself. The edge of our observable universe might not be a boundary in space, but a limit of computational processing power. Think of how a computer simulation creates the appearance of complex worlds, using nothing but ones and zeros. Digital physics proposes that our universe works the same way. But instead of binary code, reality uses quantum information as its fundamental currency. Every interaction between particles would be a computation, every physical law would be an algorithm, and every moment of time would be a processing cycle. The evidence for this information-based reality is surprisingly compelling. Quantum mechanics already describes the world in terms of information rather than classical properties. Particles do not have definite positions or velocities until measured. They only have information about probabilities. The laws of physics can be reformulated as statements about information processing and computational complexity. Black holes provide the strongest evidence for reality's computational nature. The amount of information a black hole can store is proportional to the area of its event horizon, not its volume. This suggests that space itself might be emergent from more fundamental information processing relationships. What we experience as three-dimensional volume might be a holographic projection from two-dimensional information storage. If the universe is computational, then regions beyond our cosmic horizon might represent areas where different computational processes are running. Some regions might be executing programs for universes with different physical laws. Others might be running simulations of possible future histories. Still others might be processing pure mathematics, exploring every possible logical structure that can exist. The computational universe hypothesis also explains why physical laws are mathematical. Mathematics is not just a tool we use to describe reality. Mathematics is the programming language in which reality is written. Every equation in physics would be a line of code in the cosmic program, every symmetry would be an optimization in the algorithm, and every conservation law would be a constraint in the computational system. But this raises profound questions about the hardware running the universal computation. What is the physical substrate that processes all this cosmic information? Some theories suggest that space and time themselves emerge from pure information processing, with no need for any underlying physical hardware. Reality would be software without hardware, information without a medium to store it. The computational nature of reality might also explain consciousness. Your thoughts and experiences might be subroutines in the universal program, temporary patterns of information processing that create the illusion of separate existence while actually being part of the larger cosmic computation. If reality is information, then the ultimate question about what lies beyond our universe becomes, what is the source code of existence itself, and what happens when we reach the boundaries of the cosmic program? At the edge of human knowledge lies the ultimate prize, a single equation that explains everything from quantum particles to cosmic horizons, revealing what exists beyond the boundaries of space and time. This theory of everything would unify quantum mechanics with general relativity, explaining how gravity works at the smallest scales and how space and time emerge from more fundamental structures. It would reveal whether our universe is unique, or just one pattern in an infinite tapestry of mathematical possibilities. The quest for this ultimate theory has driven physics for over a century. Einstein spent his final decades searching for a unified field theory that could describe all forces as manifestations of curved spacetime. Today, string theorists propose that reality consists of tiny vibrating strings in 11-dimensional space. Loop quantum gravity suggests that space itself is made of discrete units smaller than atoms. But the theory of everything might reveal something far stranger than any current proposal. The mathematics could show that reality has no fundamental level at all, with each apparent foundation dissolving into patterns of something even more basic. We might discover that existence is an infinite hierarchy of emergent properties, where every level of reality is built from the level below, with no bottom layer to provide ultimate grounding. Picture reality as an endless series of Russian dolls, where opening each doll reveals another one inside. Atoms are made of particles. Particles are made of quantum fields. Quantum fields might be made of strings might be made of something else, and that something else might be made of something even more fundamental. The theory of everything could reveal that this descent never ends. Alternatively, the ultimate theory might show that reality is circular rather than hierarchical. The largest structures in the universe might be built from the smallest ones, and the smallest ones might be built from the largest ones, creating a closed loop of causation that has no beginning or end. The edge of our universe might connect back to its center through dimensions we cannot perceive. The theory of everything would also solve the mystery of consciousness by showing how awareness emerges from or relates to the fundamental structure of reality. It might reveal that consciousness is a basic feature of existence, or it might show how complex information processing naturally gives rise to subjective experience. Most importantly, the ultimate theory would tell us what exists beyond our cosmic horizon by explaining the true nature of space, time, and existence itself. It might show that our observable universe is one cell in an infinite organism, one note in an eternal symphony, or one thought in a cosmic mind that encompasses all possibilities. But there is a haunting possibility that drives many physicists forward despite the challenges. What if the theory of everything is fundamentally incomprehensible to human minds? What if reality is so alien and complex that no finite intelligence can ever fully grasp its true nature? The search for ultimate truth might reveal not answers, but the beautiful and terrifying limits of human knowledge itself. Yet perhaps the most profound discovery would be what this search tells us about the meaning of being conscious beings in a universe that may be far stranger than we ever imagined. The answer to what lies beyond our universe will transform not just cosmology, but the very meaning of being human in an existence that might be infinite, computational, or unimaginably alien. If we discover that our universe is one bubble in an infinite multiverse, it would make every human life simultaneously more precious and more humble. Precious because in infinite space, the exact combination of atoms and experiences that makes you unique is extraordinarily rare and special. Humble because the scale of existence would be so vast that our entire civilization becomes less significant than a grain of sand on an infinite beach. The discovery of parallel universes would raise profound questions about identity and choice. If infinite versions of you exist making every possible decision, what makes your particular choices meaningful? Does free will matter if every option is explored somewhere in the multiverse? These are not just philosophical puzzles, but practical questions that would reshape ethics, law, and personal responsibility. If reality turns out to be computational, it would revolutionize technology and human enhancement. Understanding the universe's information processing might allow us to directly interface with the cosmic computation, potentially giving us godlike powers to modify physical laws, manipulate space and time, or even upload consciousness into the universal program. The discovery that consciousness is fundamental rather than emergent would transform medicine, psychology, and our understanding of death. If awareness permeates all matter, then techniques for enhancing, transferring, or preserving consciousness might become possible. Death might not be the end of existence, but a transition to different forms of cosmic awareness. Perhaps most importantly, learning what exists beyond our cosmic horizon would answer the question of cosmic loneliness. Are we alone in an empty universe? Or are we part of a vast community of conscious beings spread across infinite realities? The answer would determine whether humanity's ultimate destiny is solitary expansion into dead space or integration into a cosmic civilization beyond our current imagination. But the search itself might be more important than any answer we find. The human drive to explore, to question, to push beyond every boundary is what makes us uniquely human. Even if we never reach a final answer about what lies beyond the universe, the journey transforms us with each step. Every telescope we build, every equation we solve, every boundary we cross makes us more than we were before. The cosmos has given birth to beings capable of contemplating their own cosmic insignificance, and that capacity for wonder might be the most extraordinary development in the entire history of the universe. If consciousness is indeed rare and precious in the cosmos, then humanity carries an incredible responsibility. We might be among the few species in existence capable of understanding and preserving the knowledge of what reality truly is. Our survival and growth might be necessary for the universe to achieve self-awareness on a cosmic scale. The question of what lies beyond our universe is ultimately the question of what lies beyond ourselves, what we might become, what we might discover, and what role consciousness plays in the deepest mysteries of existence. The answer to what lies beyond our universe will transform not just cosmology, but the very meaning of being human in an existence that might be infinite, computational, or unimaginably alien. If we discover that our universe is one bubble in an infinite multiverse, it would make every human life simultaneously more precious and more humble. Precious because in infinite space, the exact combination of atoms and experiences that makes you unique is extraordinarily rare and special. Humble because the scale of existence would be so vast that our entire civilization becomes less significant than a grain of sand on an infinite beach. The discovery of parallel universes would raise profound questions about identity and choice. If infinite versions of you exist making every possible decision, what makes your particular choices meaningful? Does free will matter if every option is explored somewhere in the multiverse? These are not just philosophical puzzles, but practical questions that would reshape ethics, law, and personal responsibility. If reality turns out to be computational, it would revolutionize technology and human enhancement. Understanding the universe's information processing might allow us to directly interface with the cosmic computation, potentially giving us godlike powers to modify physical laws, manipulate space and time, or even upload consciousness into the universal program. The discovery that consciousness is fundamental rather than emergent would transform medicine, psychology, and our understanding of death. If awareness permeates all matter, then techniques for enhancing, transferring, or preserving consciousness might become possible. Death might not be the end of existence, but a transition to different forms of cosmic awareness. Perhaps most importantly, learning what exists beyond our cosmic horizon would answer the question of cosmic loneliness. Are we alone in an empty universe, Or are we part of a vast community of conscious beings spread across infinite realities? The answer would determine whether humanity's ultimate destiny is solitary expansion into dead space or integration into a cosmic civilization beyond our current imagination. But the search itself might be more important than any answer we find. The human drive to explore, to question, to push beyond every boundary is what makes us uniquely human. Even if we never reach a final answer about what lies beyond the universe, the journey transforms us with each step. Every telescope we build, every equation we solve, every boundary we cross makes us more than we were before. The cosmos has given birth to beings capable of contemplating their own cosmic insignificance, and that capacity for wonder might be the most extraordinary development in the entire history of the universe. If consciousness is indeed rare and precious in the cosmos, then humanity carries an incredible responsibility. We might be among the few species in existence capable of understanding and preserving the knowledge of what reality truly is. Our survival and growth might be necessary for the universe to achieve self-awareness on a cosmic scale. The question of what lies beyond our universe is ultimately the question of what lies beyond ourselves, what we might become, what we might discover, and what role consciousness plays in the deepest mysteries of existence.